Oh yeah, and Isaac, one of my colleagues, says you can use grep inside Semgrep. Yeah, so one thing is, we're very practical. And one of the features I pushed for early on when I joined was like, hey, like I want to be able to combine pattern or regexes with like Semgrep patterns. So we'll look at some examples of doing that later, but you can actually have a Semgrep rule that's like just a regex, or you could say, match this, but only if the string that's matched matches this regex or something like that.
Yeah, one reason, Clint, that I asked is because you'd mentioned that you interned at Fortify, and I think one of the worst rules that Fortify has is basically the stuff like password management, looking for hard-coded passwords, both in code and comments. And I think that Semgrep could probably be useful in both of those cases, although in the case of comments, if you're by default throwing those away, obviously that's a little harder. But I mean, you would think that it's like, okay, like look for an L value that's assigned from a string literal or something else. If you don't do flow analysis, then that's probably the best you're going to do. But they end up like finding stuff that's also R values as well, and it's kind of pointless to do that because it's not an assignment. So I just there's 99.9% of those are false positives, but when you're reviewing code and everybody's got some kind of change password functionality or something like that built into it, you get tons of false positives. So that's why I just mentioned that.
Yeah, that's a good point. So we because it tends to be a bit noisy, I don't think we've written a ton of rules like this, but I think it could be nice for detecting hard-coded secrets. Like you said, like you could say something like let's try to find like all assignments to a string literal. And there's actually a couple of things you could do with this. So with pattern regex, you could actually we have a special syntax thing called metavariable regex, where you could say, okay, like, did the thing I match, like, what does it look like? So you could actually do something like,
yeah, exactly.
And I don't think it's actually exposed through the simple UI, but there's like a different key. Actually, yeah. So I was gonna show this later, but so the simple editor is we're trying to be like, okay, what's the 80% use case? We don't want to like the kitchen sink at you. So you can do like 4 things basically, but if you go to the docs, there's actually like a bunch of other things you can do. And so one of them here, basically you can say like some module and match the method, and then we're basically going to apply this regex against what we matched here. So we could say like the sort of analogous example here is we could say sort of like metavariable regex, and then like if if the variable identifier that's getting matched looks like this, then flag, so it's not like any string literal assignment.
Right.
So we can talk more later.
I definitely think that you can do better than what Fortify does. I mean, they just like seem to have not put too much thought into that and just punted. I mean, it's like it's really no more useful than a dumb grip to me.
Well, I actually talked to their rules management people a long time about it, and it's by design. So their philosophy has been, and this may be different under Micro Focus now than when they were HPE and before, but their intent was to avoid false negatives.
Right.
And so they would rather cast a bigger net and generate more noise than to miss it. And so their assumption is that would be maybe input to a manual code review, but in reality, it just makes it almost unusable in a lot of cases, or people lose trust in it.
Yeah.
So they wouldn't change. I said, you guys should really change this, and because I pointed out a case where they should be able to, because I've written custom rules in Fortify, which is also not very easy, using their hidden documentation that you have to ask for them to get. But and I was like, I can see I wrote a rule that can exclude the cases that you're flagging. You can know are not actually right, like these kind of things. You could exclude that. Why wouldn't you do that? And like, well, we prefer to generate them just in case. And I'm like, okay, I'm not going to win that argument if that's your philosophy, but. So.
But that's the philosophy a lot of just the security community in general, right? So
yeah.
Unfortunately, when you're moving to sort of an agile world, that just doesn't really work anymore.
Yeah, I mean, Jason makes a great point, which is, and it's sort of like one of the like reasons why I was highlighting sort of like our worldview and like Semgrep's view. So we've sort of made the purposeful design decision to, based on what we've observed from a bunch of AppSec teams, is that sort of like how you get, if your SIEM is giving you like 10,000 alerts a day, well, that's not really as useful as like giving you two that are high signal, even if like you miss some. So similarly, we are trying to sort of specifically like how do we tell people things that we're pretty confident about, even if it's like in some cases we acknowledge that we're going to miss some things. And in practice, I think most AppSec teams I've chatted with agree with that trade-off, and they're fine with it. And you can always ratchet the bar up over time. But yeah, I think so. When I interned at Fortify, it was actually before the acquisition. The acquisition actually happened during my internship, which was interesting because like, oh, should I stay? Should I go? But yeah, like the people who were working there, like super smart, super motivated, very talented. I think just the focus of the engine writers and the rule writers is again like how do we find everything? How do we get like complete coverage? Versus like how do we sort of very focus on sort of like a narrow niche of high signal things. But yeah, the people who were there were great, and I'm still friends with many of them today. But yes, the sort of philosophy behind these two tools is different, and sort of where we view the future of security is, I think, is a bit different. But the people I met there are awesome. But yeah, good point, Jason.
Thanks for your comment.
Actually, Clint, the question: the engine that builds the AST, what is that built on?
Yeah, that's a good question. Okay. So I'm going to try not to rabbit hole too much. So basically, one of the hardest problems in static analysis is parsing source code into an intermediate representation. So basically, there's like a huge heavy lift before you can parse each different language. And then ideally, you then sort of like convert that into like a generic AST, which then your engine can operate on. Like every SAS tool works this way. But like different versions of languages are hard. And like there's like, like different languages are finicky and the grammar is very complex. So basically for most static analysis tools, adding a new language is like 9 to 12 engineering months of work. It's like a huge lift. We've actually taken a pretty clever approach, I think, and this wasn't my idea. It was my colleague Yoan's idea. So there's this sort of parsing project from GitHub called TreeSitter. And basically TreeSitter has, I think, like 30 grammars for like 30 languages. And basically it's like they have these grammar files, and then you can like auto-generate like a C stub that can parse that language. And then we actually take that and embed it in the fancy program analysis OCaml core and use that to more easily support more languages. So basically, if there's a TreeSitter grammar for a language, it's not free. We still have to do some tweaking and customizations. And sometimes the grammars aren't perfect. We actually push back our fixes to their grammars. Like for TypeScript, we improved it a lot. But basically, we tried to not have to manually write and port all of our grammars, which if you're doing that as a static analysis tool company, it's like massive amount of work. So we try to leverage open source and give back to open source as well. So that's like a little bit of some of the internals for how we parse in different languages. And TreeSitter is actually used for code highlighting and jump to definition and stuff like on github.com. They're actually using TreeSitter and supporting projects.
Cool. Is there any parsers for like Kubernetes and sort of CI kind of primitives like Terraform and that kind of Helm charts and Docker files and all that jazz?
Yeah. So there are grammars for a lot of those things, but actually Mark, one of our program analysis team, super smart, and he actually built a he actually built a generic mode. So it's still an alpha, but basically we were like, what if we could run Semgrep on any text file and we don't care what the language is? Like, wouldn't that be cool? And so basically, if you use the heuristic that certain tokens tend to mean certain things, like quotes tend to mean like a string, open paren or open brace or close brace like tends to denote scope, and sometimes whitespace does. Like you can actually build Semgrep on any text without even having a grammar for that file. So you don't have some of the power that you do if you have like a dedicated like a grammar support, but you can actually run Semgrep using this generic mode on any text file. So this includes like HCL, Terraform, HTML, Docker files, basically anything that's text, you can at least kind of sort of do it. It's not perfect. Like it can't do, like fancy things like we can in like the programming languages we support, but you can actually do some things. So we've had some people who've written like infrastructure as code rules and like Nginx config lints and all sorts of stuff.
For HTML, if I say every single link in a particular HTML or even raw text, then you would just use that generic one, right?
Yeah. Let me. Okay, you're stealing my thunder later, but I'll show you something.
Oh, I'm sorry.
But let's see. Let's see if this works. Cool. So someone on Twitter was like, "Hey, Semgrep is cool. Can I find script tags in HTML that don't have SRI?" And I was like, "Cool. Let's try to do that." And so basically, so this is generic mode. So again, this is on HTML, but it actually doesn't matter. Like Semgrep is not aware of HTML. This is just like generic mode. So you do have some like support for ellipses and meta variables, but it's it's still in progress. It's still alpha. But basically, what we're doing here is like find every script tag, and again, like we don't sort of care what's there, and we don't care what's inside. And then so pattern not, filter out the cases that have this integrity attribute. So basically, it's not going to flag this, but it does flag this.
And in that text mode, does it skip comments? Because I know that's a problem with some of these, is that it'll find examples and stuff in comments and flag those.
That's a good question. Yeah, let's just try. Well, first of all, let's see. So this white space, it's fine. Like, like if the script tag was in a comment?
Yeah, comment that code out.
Yeah. So sure that it's still going to find this, because again, we are not aware of HTML, so we don't have any semantic knowledge of like what it means for there to be a comment in HTML.
I guess you'd need a general and is not in a comment thing for all the rules if you want to avoid that.
Yeah, we could probably hack around with like and is not inside this, but the thing about that is like, it might work. And is not inside. To be honest, I'm like not convinced this is going to work, but we can try.
Yeah, but the way to do that is to add HTML and with JavaScript as a partner, right? And to add as a supported, so you have an AST that is now understands HTML and JavaScript, right?
Yeah. So apparently this did work. I didn't expect it to work, but So I didn't expect it to work because Dinis is right. We should have like an HTML parser which like understands the semantics of like what tags mean. That's how you would do like an actual good job with this. But at least in some cases it works without it. So that was a good question.
Yeah, because this would probably run into edge cases of where you've got these character sequences inside a string somewhere, and then you get into all kinds of fun trying to match the start and end. And
yeah, totally. So generic mode gives us like nice coverage of a lot of things at sort of an alpha level, but to do like a great job in being context aware of everything, we would probably need separate parsers. So Ash asked, can you match Java annotations? So could you match when methods are declared in controllers without an annotation? Well, Ash, I went back in time and answered your question. So this is actually a built-in example on the Semgrep editor. So yeah, so Semgrep is actually great for matching routes. Because oftentimes, at least in Flask and Java and some other language, they have like these nice annotations. So here's some examples. So this is just like an example hypothetical sort of Spring application where, let's say we have this request mapping, which says what HTTP method it is. Let's say that because of this application, how it works, it has an auth annotation, which is at authorize, and then it passes in whatever sort of permission is required, and then you define whatever it is here. And here's like some other examples. So basically, if we run this, we can see, again, like I've changed the message to basically report back all the meta variables that were matched. And let's see, I'll run it again so it's not grayed out. We can see on this right-hand side that a bunch of like interesting things in the annotations we've been able to successfully extract. So we've actually used this doing some professional services work in terms of like, let's audit all of the routes. So here we see that we're pulling out the method name. If there's a path defined, is this a get versus a post? What are the permissions? Yeah, so basically, we have already written code for like sort of our internal project work where it's like, okay, we do a little bit of code audit where like this code base, this is how they define auth checks, and then let's find all routes without this authorization annotation. And actually later in the workshop, the example that we'll do together is finding unauth Flask routes and then adding a autofix suggestion such that it will auto comment on pull requests to say, hey, looks like you're not doing a JWT check. Please add this in. So yeah, we'll do that in a bit. But yeah, does this answer your question?
Yeah, thank you.
Cool. Yeah, thank you.
I might have missed this nuance, but are those, the way that those rules are written, are they order dependent on the, like if authorized was before request mapping as an attribute, would it break?
Yeah, that's a good question. So I believe annotation order does not matter. So like, I think our pattern could have these in either order and this code could have them in either order. Mm-hmm. But there is actually some nuance in pattern writing where I believe like if you have a series of like or clauses, so like if any of these match, I believe that it does match the first one. So like, for example, here it's like if it's this or this or this, if this first one matches, I don't think it's going to run the second or third one because it's like it's already matched. So you don't need to see that it matched multiple times. So what that means is you generally want to write, or one heuristic I use is like, let's write a more restrictive one first, and then like more general below, because then, for example, if you want to extract as much sort of meta variables as possible out, then you have the chance of like matching the most first, and then gradually you get more general, where if the general one is first, you may not ever run the more specific ones. But annotations are matched order agnostic, in my experience. But yeah, excellent questions. Cool. So I have an example that I would like you all to try. Also, if you, let's see, I'll paste a link to the slides because these might be, there's going to be a couple of challenges listed in here. And it'll be probably easier for you to just go click on the link and then you can sort of write in semgrep.live yourself. Okay, so on slide 37, this was the example we just did together. And I included a couple of slides here in the middle just for sort of easy reference. So I'm not going to talk about them, but they're just sort of like an overview of like meta variables and the ellipsis operator and stuff like that. Okay, but if we get to slide 45, this is where the examples start. So let's see. So I'm actually going to, so I thought something that would be fun is like, can we basically like solve these together? So I'm going to tweet another prompt, and then, but this is what it's going to be, this Ruby exec example. And then feel free to try to solve it and then respond to me if you want to. You also don't have to. You know, if you think that that's stressful, like, don't worry about it. Yeah, so in Ruby, exec runs the first argument as a shell command. This could lead to arbitrary code execution if, you know, user input is the first argument. And so this is basically like an adapted version of what we looked at for Python, but for Ruby, just to show that, you know, we can do this in any language. Okay, so let's see, there's a little bit of nuance here because, yeah, I tried to make it like a little more complicated so that you could play around with meta variables as well as the ellipsis operator and combining clauses. So one thing that's interesting about Ruby is that if there's just one argument, it'll do like shell expansion, but if there's more than one argument, it won't. So the goal here is let's write a Semgrep rule such that there's only one argument and that first argument is not a string literal. And just some like tips. So in this test code thing, I've sort of annotated what I expect to match and what I expect not to match. So if you see like rule ID and then some string, this says I expect Semgrep to match this. And this rule ID, if you go to the advanced tab, is just the same thing. So whatever is here, the syntax is like rule ID colon, and then whatever this ID tag is. And then if you do like a comment and then just OK, you can also do OK colon, and I think the rule name to be more specific. But basically that's like, OK, I expect not to match that. OK, so I've included a bunch of test cases. And yeah, see if you can match this one, but not any of the others. I think all of the other ones were to not match. Yeah. Okay, so I will give you a few minutes to work on that. Again, the specific example is here. The tweet itself is here. And
could you just paste that into the chat window too? So, the link.
Yeah, I believe I did. Do you?
Oh, okay. I didn't check it.
Oh, I just posted it like 2 seconds ago. Yeah, and as you're working on these, think like, okay, like what's something in my organization that I really want to find? Because ideally, the last bit of this workshop will be like, just, you know, you send to me. Oh, also, I think, sorry, I forgot to reference this. So if you, like, as you find the solution, you can say, you know, like Ruby exec solution or whatever, and then save it. And then now this has given it sort of like a permanent URL here. So you can then include that in your tweet, or, you know, send it in the Zoom group chat, or do whatever you want. So this actually has been really nice because like when we're troubleshooting issues internally, or other people have questions and they're like, hey, I want to find this code, being able to easily share a link is great. Okay, so Andre asked, performance-wise for huge files, how does it perform compared to grep? So grep and ripgrep are obviously going to be significantly faster because we are doing a ton of work that they're not doing. We found in practice that we, depending on what your patterns are, there's so there are some more general things that you can do, like if you use, say, like a lot of ellipses operators, or if you use some other more advanced operators that do like deep expression matching to sort of do fancier things, that can slow it down a little bit. But I would say in practice, we often get like 10,000 lines of code a second or so. So we can scan like a full, like a bunch of rules on like a massive code base in, so it's fast enough to run like in IDE on file save and not feel horribly slow. If you include it in GitHub as a linting tool, we only scan like the files that are changed, and usually a lot of the time to run is actually based on the GitHub Docker image booting up, not our scan. Our scan is actually faster than booting up the GitHub Action Docker image. So I would say, on like one huge file, it depends on the pattern, it depends on how long the file is, but I would say, probably less than a second if it's just one pattern. If you're running like minified JavaScript, for example, if you're bundling in like thousands of lines of code into one file and you're running rules that are like very permissive, then it could be like a few seconds. Actually, okay, let me like bring something up for a second. I have like some random repos that let's see. I forgot where I put it. No, there's my second monitor is above this one. Okay, let's say GitHub Ghost. So this is just like to give you an idea of speed. Okay, so let's just like clone this guy down into temp. Maybe I probably should have done shallow clone, but anyway, basically I'm just going to run like the default Semgrep rule set on this random repo that's like a real professional code base, just to see like how long it takes.